All right, we're going over 2.25. Start thinking part says Kieran makes $3 for each hat she sells and $5 for each shirt she sells. She only has at most 20 hats to sell and at most 50 shirts. She wants to make more than $90. So what are the inequalities that represent this? Well, we have three different constraints. We have the constraint that has to do with the amount of money she needs to make. We have the constraint about how many hats, and we have the constraint about how many shirts. So the one that has to do with the amount of money she makes is $3 times the number of hats plus $5 times the number of shirts, and that needs to be the amount she makes needs to be greater than 90. It does not say at least, it says she wants more than $90. The next one says you have at most 20 hats to sell, so that would be x is less than or equal to 20, and then y is less than or equal to 30 for you have at most 30 shirts to sell. Then you're supposed to graph these inequalities. I went over and graphed. I used my arrows instead of shading. So anything that has only a single set of arrows going to it means it would be shaded once. No arrows going to it is shaded not at all, and 3 sets of arrows shaded would be a solution to the system because there's 3 inequalities. So just check how many arrows are pointing at it to figure out if it's shaded not at all, once, twice, or 3 times in this case. Once we get this, it says give a combination of hats and shirts that meet all the constraints. The one that I did was 10 hats and 20 shirts. You can see that that would be shaded 3 different times, which means it is going to be a solution to all 3 inequalities, which were the constraints. The next one here was talking about this graph. On your paper copy, I went over and actually drew arrows in to show which direction everything was being shaded in. That horizontal line is being shaded down, the vertical line is shaded to the left, and then the dotted line is shaded above. So it says this is going to be the same thing. The only issue is now she only has 5 hats to sell and 8 shirts to sell. What does the graph tell you about this situation? And all I notice here is that at most there's things that are double shaded. There is nothing that is triple shaded, and there are 3 constraints. So that means at best it is going to only meet 2 of the constraints. It's going to have the certain number of hats and make a certain amount of money, but it is not. There's not going to be a case where she is able to make the correct amount of money and sell that number of hats and shirts. There's just not enough hats and shirts to be able to sell. If you think about this, it says $3 a hat, so max you can make is 15 bucks off of hats. And then it says $5 for shirts. 5 times 8 is going to be 40, and 40 plus 15 is 55. So the most she can make is $55 with that number of hats and shirts. She's supposed to be making 90. It says according to the graph, it says he, it's supposed to say she. According to the graph, if she could not get any more than 5 hats, then how many shirts would she need to be able to sell to meet this goal? So when we're looking at this, you can see that the horizontal line is talking about shirts, and the shirts are currently at 8. And you ask yourself, how much higher would this have to be so that you would end up being able to get triple shading? If I brought it up to 15, then it's almost a triple shading, and it's basically showing that if you go slightly over 15, then you would be able to have, I don't know if you could see my cursor, but you would end up having some triple shaded stuff where it is going to be less than 5 hats. It's going to be the correct amount of money, and it is going to be, once again, she's going to need more than 15 of the shirts. What students did now is they had this table here, and the table talked about the calories for each one of these items, the protein for each one of these items, the sugar for each one of these items, the fat, and the fiber. And we were looking at one specific case. And what it was this kid named Tyler was trying to make trail mix. He's written the following constraints to describe his recipe, determine which ingredients he is using, and explain what each inequality means for the situation. So what I was able to do here is I went and looked at the different inequalities, and I saw that one of them had the 4.76 and one had 6.67, and I saw those came from chocolate and coconut. So I found out that 2 ingredients that he was going to be using was coconut and chocolate. And then I tried to figure out what each one of these constraints actually meant. When they say x plus y is greater than 50, and I can see down below we have 4.76 times x. that leads me to believe that X is going to be the number of grams of chocolate, and Y is going to be the number of grams of coconut. So the X plus Y needs to be greater than 50. Says you need to have more than 50 grams in total for your chocolate and coconut. Okay. The next one is 4.76. Let's see what 4.76 is talking about. It's talking about calories. So in this one, it is saying that the calories needs to be no more than 400, and it says 400 grams. That's not correct. That's supposed to say 400 calories. Total needs to be less than or equal to 400 calories. This one is talking about calories. I accidentally wrote grams down there. The next one is talking about the 0.67. When I look at what 0.67 is talking about, it's sugar. So that is sugar inside the chocolate, sugar inside of the coconut. And this is saying that there has to be less than 30 grams of sugar. The next one says X must be greater than 0 and Y needs to be greater than 0. X is the grams of chocolate, and Y is the grams of coconut. So this is just saying that you have to have at least some chocolate and you need to have at least some coconut. They then go over and give you a situation here and they graph it. So when we have this and it's graphed and you can see all of the different shadings, and it says the following graph models all the constraints. Give an example of a combination that meets all the constraints. So I'm trying to find something that is going to be shaded by all of them. There are 1, 2, 3, 4, 5 different constraints. What is something that is shaded by all of them? I got 40 grams of X, which is 40 grams of chocolate, and 20 grams of coconut. That would be shaded by all of the constraints, which means it meets all of the constraints. It's a solution to all of them. Now, when we're going over the homework here, the first one, this confused me a little bit because it's not two different things. It kind of is, but it's a little confusing. They're saying one was talking about a large package of papers and the other one is talking about a small package of papers. And they give you the two inequalities, which are your constraints. And when you're looking at these constraints, it says explain what the second inequality could mean for this. Well, the first one is obviously they say that there's packages of 24 and there's packages of 6, and that it says it's greater than or equal to 200, and 200 is how many notepads you need. So this is saying basically how can we end up with at least 200 notepads, buying big packages and small packages of the notepads. And the next one, trying to figure out what the heck this could mean. It says something about less than or equal to 160. And when I look inside of the problem, 160 is talking about cost. So this inequality must have to do with cost. And the 16 must be talking about how much it costs to get a big package of notebooks, and the 540 has to be the cost of a small package, because the cost for the big packages and small packages have to be at most $160. So they go over and graph these. Number 2, it says, here's an incomplete graph of the inequalities in the system because all they showed were the boundary lines. And it says, which graph represents the boundary line of the second inequality? So the way I did this was I just found out the y-intercepts. So the top one, I did 200 divided by 6 to find its y-intercept. And then the bottom one, I did 160 divided by 5.4 to find out its y-intercept. And I found out that the second one, if you do the 160, I'll do it right now, 160 divided by 5.4, that gives you 29.62. So that one, the bottom one, has to be the one that has a y-intercept for the boundary line of 29 point something. So I pointed to it with an arrow. Then I went over and knew that that one was the one that needed to be shaded. I tried 0, 0, and I found out it was shaded below, and the other one was going to be shaded above. And you can see the part that is double shaded. And it says, give me a combination of big packages and small packages that would make this true. And I found that 8.4 was something that was double shaded. The next one here is talking about Jade is mixing up butter and sugar to make a tasty syrup. Butter is mostly entirely fat, so we're just going to consider it fat. Fat is 9 calories per gram and sugar is only 4 calories per gram. She needs to have at least 4 grams of butter and 10 grams of sugar. The mixture can have at most 100 calories. The graph below models these constraints. The constraints are X needs to be greater than or equal to 4. There needs to be at least 4 grams of butter. There needs to be at least 10 grams of sugar. And then you have the inequality that represents the fact that it has to be less than 100 calories. I've gone over and labeled these with A, B, C, and D. On your copy, there are arrows kind of making sure you know which way things are shaded. So it's asking what each one of these things mean. So A, all of the points in A are double shaded. So what does that mean? It means there's at least 4 grams of butter and 10 grams of sugar, but it's too many calories. Okay, that's why it's not shaded by that diagonal one that's talking about number of calories. Now B, on the other hand, is going to be, if we look at this, B is going to be shaded by all 3 of them, which means it covers all constraints. It's a solution to the system. It's going to have at least 4 grams of butter, 10 grams of sugar, and it's not going to be over 100 calories. It's going to be at most less than or equal to 100 calories. C is going to be shaded by 2 of the things. That one is going to be at most 100 calories, and it is also going to be at least 4 grams of butter, but it doesn't have enough sugar in it. And then the last one, D, is going to be at most 100 calories, but it does not cover the constraint that is talking about fat and sugar. On this one right here, it says a stylist is charging $15 for a haircut, $30 for a coloring. The haircut takes on average 30 minutes, while coloring takes 2 hours. We're supposed to be writing 2 constraints here. She can only work up to 8 hours a day. So I know that 2 different things we're talking about is money made and the amount of time she has. So money made is going to be $15 times the number of haircuts, $30 times the number of coloring, and you want to have at least $150. Now the next one, you got to be careful because 30 minutes is actually half of an hour. So that's 0.5 hours times the number of haircuts plus 2 hours times the number of colorings, and that has to be less than or equal to the 8. When you go over and graph these, you have some things that are shaded once, some things that are shaded not at all, and some things that are shaded twice. It says identify a point that is a combination of haircuts and hair colorings that will meet all the requirements. And I saw 10 and 1 was going to be shaded twice, so 10 haircuts, 1 coloring would work. Identify a solution that just doesn't really make sense. If you look, you can see it looks like 11 and 1/2 seems like it's double shaded, but how are they going to do 11 haircuts and half of a coloring? I guess possibly they could say I just want half of my hair colored, but it still just doesn't make sense. You could also look at something that had half of a haircut. That would be weird. All right, thanks for watching.